Hello everyone. In this video, we will be discussing about design considerations and the material selection process. Before that, we will have here a short review on the machine design process. We know that in machine design, any other kind of design, there is no standard procedure or any rigid rules can be specified for the designer. But these steps are generally followed. So what is the very first step is a problem to be solved or the desired purpose of the machine is completely and clearly stated. And the second point is all the possible mechanisms that will provide the desired motion or the set of motions should be selected. And the third point is forces acting on and energy transmitted by each element of the machine are determined. The next one is best suitable materials is selected for each of the machine element. Fifth one is allowable values of stress and deflection are determined for each machine element depending upon its material and functional requirement. Sixth point is size and shape of each machine element is determined so that it can withstand the applied loads without failure. Seventh one is dimensions of the machine elements are modified considering the manufacturing aspects. And the last one is assembly and detailed drawings of the machine are made with complete specification of materials and manufacturing methods. So there is no proper way of defining the machine design process. So this is the one way which I'll be following for further understanding of the design considerations. So the strength and stiffness are very important factors that we need to consider in the machine designs. So when I talk about the design considerations, there are numerous parameters are there. Among that, the very two important parameters which I need to give prominence to the strength and stiffness. But the designer always have to keep one thing in their mind while designing a product. Apart from these two factors also, there are some other considerations even that also plays a very major role in some cases. So what are all they? Which the first one is the functionality, second one is the strength, third one is the stiffness. So we know that these three plays here, these three are the very common consideration we will be usually discussing in any kind of designs. So apart from this, whatever we are discussing or whatever we are considering is nothing but wear, corrosion, thermal properties. So when I talk about the thermal properties, I can say like the applications where it is related to the heat related conditions, then this thermal properties will be in the front line. Some products, say for example, let me talk about a bench wise. So bench wise, there is no requirement of the considering thermal properties. So the applications actually decides whether we need to consider this parameter or not. So the next one is the surface finish. Next one is the lubrications. Again, one more common factor, lubrications. Lubrications where is there any possibilities of friction during the operations, then probably we may consider this lubrication factor. Next one is the weight, noise, shape. So all these things will not play a major role in all the designs. Depends on the applications, these factors may be considered. So apart from these things, even we have a few more considerations like size, safety, reliability, manufacturability. So here when we speak about the manufacturability, the same product or the same part can be manufactured by using many manufacturing method. Say for example, we can go with the casting process, or we can go with the machining process, or we can go with the unconventional machining process. Like any methods are there, but due to some errors in the manufacturing process, sometimes even we may land up with the failure design. So even it is very important to identify what is the right manufacturing process to be considered for the making of one particular part in the design. So next one is the utility, maintenance, liability, cost. Some this is also a very important parameter we need to consider. Some design, if you take, means some materials will fulfill all our requirements. Depending upon the availability, we'll be taking that. But when I'm talking about the durability, even gold is also very good in durable, and even Copper is also very good in durability. So when I have to select among these two, I need to focus more on the cost. Even though both the materials are good in durability, here I need to give the preference to the cost. So likewise, we need, when we are comparing the materials, even we need to check along with availability, we need to check the expense of that particular materials also. Next one is the life, then control, volume, marketability, and remanufacturing. The last point is also very important. There are some design products, so it cannot be remanufactured. Once the product is made, means maybe the small changes can be done. We cannot remanufacture the whole product. So even we should be very careful before investing or before making any one prototype or the real model. So, among all the design factors, I will be discussing very few factors. So, in that first, I will be discussing about the selection of materials. So, material selection is a very vital step in the process of machine design, and the selection of material depends upon the following aspects. So, the first one is nothing but the performance requirements, where I will be selecting the material considering the design constraints and the performance requirements. Example: loads acting on the member, size and weight constraints, environmental conditions, desired reliability and durability, etc. So even though many factors are there, I will be considering mainly these requirements. I will be considering that. So the next one is nothing but material properties. Along with the selection of material, performance requirements are even compared with the properties of materials to select the best suitable material. For example, stress level estimated for any machine member is compared with the strength of the available materials. Properties can be physical, maybe melting point, coefficient of thermal expansion, thermal conductivity, specific heat, specific gravity, electrical conductivity, magnetic properties, etc. And when we talk about the chemical things, it may be a corrosion resistance, reactivity with acids, bases, waters, etc. So even we have many physical and chemical properties that also we need to consider before we estimate the stress level with the other products. So we need to focus even more on the mechanical properties of the materials. So the mechanical properties of the materials describe their behavior under the action of external forces, and it is very important in the determination of shape and the size of the components. So here I have listed down some of the important mechanical properties like strength, ability of the strength, uh, stiffness, elasticity. We will see each property with the definitions. So how can I define strength? Strength is nothing but ability of your material to withstand external forces without yielding or fracture. And the second important property is the stiffness. It can be defined as ability of a material to resist deformation under the action of external forces. And the third mechanical property is nothing but elasticity, which is nothing but ability of a material to regain its original shape and size when the external load is removed. I have listed down all these mechanical properties of materials in the proper order, so that if you make any mistakes when we are doing the reverse engineering, if I find that so and so property is not fulfilling my requirement, means then we can follow the same order. So the next mechanical property is nothing but plasticity, which can be defined as the ability of a material to permanently retain the deformation produced due to the external load. Examples we can say like some stamping operations, coins and other things. And the next property is the ductility, which is nothing but ability of a material to have large plastic deformation without fracture when subject to the tensile force. And most of the students will be having a doubt about how to measure the ductility. Maybe they know the definition. So usually the ductility is measured by the percentage of elongation and the percentage of reduction in areas, and the ductility will keep on decreases when we increase the temperature. This is also another important factor we need to remember. And the next property is nothing but malleability, which is defined as the ability of your material to have large plastic deformation without fracture when subjected to compressive forces, and the malleability will increases with the increase of temperature. In case of the ductility, it decreases with the increase of temperature, but in case of the malleability, it increases